Okay, binary addition works on the XOR gate principle. If you know what an XOR gate is, that's fine. I'll explain sort of what it does anyway now. So if you add a 0 and a 0 is equal to a 0, a 1 and a 0 is equal to a 1, a 0 and a 1 is equal to a 1, and a 1 and a 1 is equal to a 0. But with this you have, I should say, this is not equal to 0, I should say it's equal to 10, I guess. So when both are off, the output's off. When one's on, the output's on. When both are on, the output is off, but then it adds 1 to the next column. So let's do an example. If the number was 0, 1, 0, 1, add 0, 0, 0, 1. Keep it simple. So you say 1 to 1. This, if you look at the rule here, gives you 0 with a 1 carry out. So 0, 0 gives you a 0. And 0 and a 1 actually gives you a 1. So you don't normally write a 0 in, but you add all three up. And then if you had a 1 and a 0, if you look here, is a 1, and then 0 and 0 is a 0. So the output is 6. So this is 5, this is 1, so that's right. Output 6. I'll do another sum as an example. If it was a 1, a 0, a 0 and a 1, and you wanted to add 1, 0, 1, 0, you can say 1 add 1, 1 0 is 1, 0 add 1 is 1, 0 add 0 is 0, 1 add 1 gives you a 0 with a 1 carryout, but this is a 5-bit output, and that's because a top in a 4-bit is 15, plus another top in a 4-bit is 15, so that's 30, which can only be stored in a 5-bit output, because maximum of 5-bit is 16 plus 8 plus 4 plus 2 plus 1, which is equal to 31. So 30 goes into that. Okay, let's think about binary subtraction. So if you had two numbers, let's say 0, 1, 0, 1, which is equal to 5, minus 0, 0, 1, 1. What you do, you convert the second number and you reverse every symbol. So I'll write the top number again. So the bottom number will be 1, 1, 0, 0. But when you do this, you also have to plus 1 to it. So this will be 0, 1, 0, 1 plus 1, 1, 0, 1. Okay, so the answer from this, you just add the two up. So 1 plus 1 will give you 0 over 1 carry out, so that will give you 1. This will give you 0 over 1 carry out. This will give you 0 over 1 carry out. Now if you ignore that final 1 for a second, this was equal to 5 and this was equal to 3. The rule is, with the 5th bit, if it's equal to 1, it's positive number. If it's equal to 0, it's a negative number. So you use the 5th bit to tell whether it's a positive or negative. Same as if it was 8-bit, you'd use a 9th bit to see if it's positive or negative. So let's say 0, 1, 0, 1, 5 is a good number. Minus 0, 1, 1, 1. That's 5 minus 7, so we should get a negative number. So you're going to reverse this. So I'll write the top one again. Reverse this will be 1, 0, 0. But then obviously add the 1, so it'll be that. So then you add them together. So yeah, 1 and 1 gives you 0 over 1 carry out. So it just goes there. 1 and 1 gives you 1, 1 that gives you 1, and then obviously if it hasn't been changed it's 0 by default. So this is equal to 5, this is equal to 7, 5 minus 7 is equal to minus 2, so this is a negative. Now this, you have to add it up in the rule of 2's a complement, so minus 8 plus 4 plus 2 is equal to minus 2, which is the answer here. So technically you do not need this negative thing. It's just if you're building something or making a calculator or something, then you will need it, but you don't. I'm saying it's good to know it exists if you want to use it for something.